Okay, so this video will help you for exercise 4B, which is just builds on 4A with the midpoint work and is a continuation of C1. Okay, now the C1 work you will use in this exercise is the work that we did on equations of straight lines. Okay, so y equals mx plus c, that kind of stuff. Although the one you'll use the most will be y minus y1 equals mx minus x1, which is the one if you've got a gradient and one coordinate. Remember, you have got this one as well, which is the equation if you've got two coordinates. But as I said in C1 in my lessons, if you've got two coordinates, it's easier just to find out the gradient and then pick one of the coordinates and use the first one. So that gives you less to remember. Okay. Just as a reminder as well, this is the formula for finding the gradient. So it's just the difference in y's divided by the difference in x's, which is the y's divided by run. Okay, and at the end of the chapter in C1, we looked at the perpendicular lines. So remember, if the gradient of one line is m, then the gradient of its perpendicular line is minus 1 over m. So it's that negative reciprocal. So effectively, you flip the gradient upside down and change the sign. Okay, so those are all the things you'll need from C1, and I'm just going to assume that you know them. Okay, so if you're rusty on any of that, then it's probably a good idea to stop this video and do a little bit of revision and revise some of that work from C1, just so you're happy with it. Right, so this question we'll do then, ready for 4B, it's not so much showing you how to do a type of question, but how you approach a more problem-solving type question, okay? So we've got a diameter of a circle with the coordinates of the end of the diameter minus 1, 4 and 5, 2. The line L passes through seems perpendicular to AB. Find the equation of L. All right? So there's a couple of keywords there that we need to look at first. We've got the diameter, so we know that A and B are the ends of that diameter, so on the edge of the circle. We know that L is perpendicular to AB. So that'll give us a bit of information, and we want to find the equation of L. So we should be thinking, well, it's y minus y1. I've got a perpendicular thing to deal with. Okay. Now a sketch makes this a lot easier. Okay. And if you just think about where these coordinates are going to go before you do your sketch as well. All right. So minus 1, 4 is going to be kind of there, and then 5, 2 will be to the right and down a bit because it's less than 4. So sketch out a quick circle. So therefore, A will be over here towards the left because the x-coordinate is lower than for B, and it's also lower for the y-coordinate as well. So that's the kind of relationship to be. Although it's a sketch, you want to kind of have it fairly, representing what's going on. So the centre of the circle is labelled there, and we know L goes through the centre and is perpendicular to that gradient. So that's what we've got here. The key things is the fact that the centre is the midpoint. Okay, so that's where we're going to bring in the work from exercise 4A. All right, and we know that centre, or that midpoint, lies on L as well. So that also gives our coordinate that we're going to use eventually to find the equation of L. So sketch just makes it a lot easier to work out what you're doing. The next thing you want to do is try to think of a plan of how you're going to solve that. So we start off with what we want to work out. So we want to find the equation of L. So we know that we're going to end up using y minus y1 equals mx minus x1 at some point. So now we look at the information that we need to be able to use that equation. So we need a gradient of L. Okay. Now let's not worry about where it's going to come from for now. We're just formulating the plan. Eventually, this will go on in your head. We know it's perpendicular to AB, though, so obviously, if you want a gradient of L, if it's linked to the gradient of AB, then it makes sense to work out the gradient of AB. Okay, so that's the next step in our plan. So we need to work out the gradient of AB. Okay. So what else do we need for y minus y1 equals mx minus x1? And we're going to need a coordinate as well. So we need the x1 and the y1 values. So we think of that. So stick that down on our list. And then now we just look at, on our sketch, how are we going to get that point? Okay, so the only coordinate that we know for definite lies on L is the coordinate at the centre of the circle. So we need to work out the centre of the circle, which is the midpoint of AB from our sketch. So we need to work out the midpoint of AB. Okay, which is C. Almost a nice spelling mistake there. Right, so there we go. So now, if you look at your plan, basically work from number 5 back to number 1. So the bottom one is our starting point. At the top of that list is our end point. So we just work back through that plan backwards. Okay, and that breaks up a problem for you. All right, well, eventually you'll be doing that in your head, but it might be an idea to actually write a list of that plan so you've got a frame to work on. All right. Remember, each of those little points are going to be picking up method marks and accuracy marks for you in an exam as well. So if we work out C first of all then, so using the formula from 4a, we just add the x and y coordinates together and divide by 2. So that gives us C is 4 divided by 2 and 6 divided by 2, which is going to be 2, 3. Okay, so that's 0.5 then. So and 0.4, because we've got a point on L, because once we've got our gradient, our centre of the circle, we've also got our midpoint. So we've got a point on L. So gradient of AB next. Sorry, just interrupted by some of your 9 students then. So gradient is going to be y2 minus y1 equals x2 minus x1 from C1. So if we work that calculation out, we get our gradient of AB, remember, not a gradient of L. That's going to be 4 take away 2 minus 1 take away 5. Make sure you do them in the same order. So the x and y from the one coordinate take away the x and the y from the other coordinate. That's going to give us 2 over minus 6, which is just minus a third. Okay? And then, so if our gradient of AB is minus a third, what's our gradient of L going to be? It's easy. It's that negative reciprocal, is what we call it. But in effect, all you do is you flip it upside down and change the sign. So it'll be 3 over 1 and changes from a negative to a positive. So it's just going to be 3. Okay, so at this point now might be a good idea to read through the question again if you haven't written a plan. Or look back at your plan and think, well, I've done my gradient of AB, I've got my gradient of L, so now I'm on the final bit, I just need to find out my gradient of L. Okay, so M is 3. I've got my coordinate, just to bring everything together, is 2, 3. Okay, so y minus 3 is equal to 3 brackets x minus 2. And if we simplify, expand that and simplify it, we get 3x, and we'd have minus 6 there. And if we imagine minus 6, but we bring in that minus 3 across, we'd have minus 6 add 3, so it's going to be minus 3. Done. So that example wasn't so much showing you how to do a type of question, but how you would approach a more demanding problem, really, okay? And that technique, you want to think about trying to apply that to any question you do in A-level that's slightly more challenging and one that makes you think more, okay? There's nothing wrong with those questions that are tough and are hard, but you want to have a strategy of how you approach it and how you begin to solve it. And the first thing I did was I highlighted any keywords and information, and important information. All right, so like what it was asking me to do, the fact it gave me a diameter, the fact that it had a perpendicular thing in there. Okay, so key things are going to help me with the problem. The second bit is I did a sketch. Now, obviously, you're not always going to be able to do a sketch, but if it's a coordinate geometry question, problem, you definitely want to have a sketch because it does make it a lot easier for you. So if ever possible, always do a sketch. Your third point is the crucial bit, is to think of a plan. And, you know, maybe write it down as a list of steps like I did. Because again, then that stops you, that slows you down, it makes you think, and it makes you think of a strategy to solve the question. Okay? And this is an important one, so I'm writing in red, is check for awkward bits. Okay? So bits that where, if it was a problem in an exam where they could potentially take a mark off you. I'm thinking, so, you know, do they want, for example, relating to this, do they want the form of your equation in y equals mx plus c, or do they want it as ax plus by plus c equals 0? Okay, so make sure it's presented in the way that it's asked to as well. And the way to double check that you've done that, really, and this is a very important bit, is at the end of your solution, you want to review the question and just make sure that you haven't left anything out or you haven't made a mistake. And actually you've answered it and given what the question has asked of you. Okay? Right, good luck. Off you go.